In the field of data science, AI, or machine learning, you often deal with raw data. Raw data generally is not clean, and it contains quite a few errors in real world. And so cleaning the raw data is a very important process in data science, AI, and machine learning domains. As an example, look at the data that you can see on your screen. So this is the data set for iris flower. And this data set has got four independent variables. So namely sepal length, sepal width, petal width. And the last column, which is a dependent variable, is a species, and that it contains the type of the flower. I have edited this data set in order to demonstrate the data cleaning process. As you can see on this data set, that there are some values which I have highlighted in red background, which seem problematic. So as an example, the first value is minus 5.1. Now you know that the length of a flower can never be negative. Another value is in this row number 6, and it's 500, and we know that 500 is a very large value for any flower. 400 is also a very large value, which is not possible. Then you have the values in the row number 10, which is a missing value. And then on the row number 12 and row number 13, these two, which I've highlighted in red, you can see that these rows are actually duplicate. So in real world data, you will often come across data which have got problematic values. And in this session, we will deal with techniques as to how to handle these problematic values in the dataset and clean the dataset. So first, what we'll do is we'll visualize the data. We'll visualize the missing values, and then we will deal with some unusual values. For example, negative values, which we would know that it's not possible. Then we will deal with missing data. And then we will deal with outliers. We'll deal with duplicates. Okay, so let's start the coding session. So first, I will import pandas, which is a library, as pd, and then I will also import matplotlib because I'll need to do some plotting as plt, and I will import seaborn as well. Import seaborn as sns, right? Okay, so first we will read the data frame. So this Excel sheet, we'll just read this data as in a data frame. So we'll say pd df standing for data frame equals pd.read excel, and then I will copy paste the name of this Excel file, and I will just write that Excel file here. Okay, so once I run this code, you will see that we have created a data frame which contains the data that we were seeing in the Excel file, and you can see the same problems here. So we are focusing on the column sepal length, and you can see that some values are negative, some values are too high, there are some missing values, and there's some duplicate rows as well. Okay, so first we'll just print info, df.info, and if we print df.info, then we will see that there are some missing. So sepal length has got one missing value, and other columns are they don't have a missing value. So we've seen that this sepal length has got one missing value. Okay, now before we proceed, what I generally do is I create a copy of the data frame. So and this will help us to compare the original data frame with the cleaned data frame in the end. So once I create a copy, so this df.original, we won't touch it. We will do all our data cleaning on the df data frame, and in the end we'll compare this original data frame with the clean data frame. Okay. All right. Now what we'll first do is we'll just quickly visualize the missing values. So I'll just plot it, and then I'll just plot a heat map using a seaborn library, and then I will say df dot is NA, and then okay, so when I run this, you can see that this heat map has been shown, and in the heat map you can see that the sepal length has got one missing value, right, which you can confirm by this one, right? So the eighth value is the missing value, which is in the heat map. Now for this small data set, it doesn't matter too much, but I think if you had a very large data set, data frame, then visually being able to see the missing values helps a lot. Okay, so having seen the the missing values, then what we'll do is we'll first deal with the unusual values. Now we know that looking at the data frame, that negative value is not possible. A value of 500 and 406 is not possible either. Now you will have to decide that what is a unusual value, right? Depending on the problem at hand. You can talk to domain experts, so on and so forth, but this, what is an unusual value, or what is a value which is practically not possible, you will have to decide that depending on the data science problem you're dealing with. And since we are focusing on the sepal length, we'll just create a colName, and then we will instead of every time writing sepal length, we will just we'll just use this colName variable, right? Now in order to, so what we decide is that any value which is less than 0 is not possible, and any value more than 400 is not possible. Let's say that's our assumption. So what we can do is we can iterate the data frame df.index, and then we can say if df.loc x comma colName, if this is less than 0, which means if this is negative, or if df.loc x comma colName is greater than 400. If that is the case, then we can set df.loc this value x comma colName as we'll put it as a missing value. So we'll say pd.NA. So what this loc does is, loc is a feature wherein you can access the elements of a data frame using rows and columns. All right, so row and the column name, you can access the elements. So effectively here what we are saying is that pick up, go through all the rows of the data frame, and if any value for the sepal length column is less than 0 or more than 400, then replace it by NA. Right. So when I run this code, you will see that for the df.location, it should have replaced it by NA, which it hasn't. So let's see if there's an error. Oh yeah, it says colName is not defined, so we need to run this code as well. So now we define the colName, and then we run this code, and after that you can see that in the original data frame the minus 5.1 has been replaced by NA, the value of 500 has been replaced by NA as well, and the value of 400 has been replaced by NA, and there was already a null value, a missing value. So now there are 4 missing values, right? If I now do this df.info, if I run this, then you will see that the column sepal length has got 4 missing values, right? Okay, so so now we have dealt with the unusual values, which we know that they are not possible. Then the next thing we'll do is we'll deal with the missing values. So at the moment, the data frame has got 4 missing values for the sepal length. Now there are different ways to deal with missing values. You can either replace the missing values with some with another value. For example, you can calculate the mean, median, or mode of the column, and then replace all the missing values with either mean, mode, or median. That's one option. The other option, which is easiest option, is to just drop all the rows with the missing values. The problem with that approach is if your data set has got less values, which is the case in our in this scenario, then if you drop the rows with missing values, you will lose the data. So again, you will have to decide what strategy you adopt depending on the problem you are working with. So in this case, we'll simply just, to keep things simple, we just simply drop the missing values. Now before the dropping the missing values, we will just get a count of all the missing values. So we say null dot sum, and then if I print this, I say print. Okay, so here what I'm doing is I'm saying df.isnull.sum. So I'm adding all the getting a count of the missing values, and then if I run this code, you can see that it gives me a very simple result, which shows each column has got how many missing values, and here you can clearly see the sepal length has got 4 missing values. And again, this is a very small data set which I've created just for the demo purpose, but if you're dealing with a bigger data set, then something like this will be very helpful and will give you a deeper insight into the state of affairs. Okay, so now what we'll do is we'll simply drop the missing values. So we'll say df.dropna, and we'll use parameter here, which is inplace true. And what inplace true does is df.dropna, this function will drop the missing value, drop the rows with missing values and return you a data frame. But if you wanted that the missing value should be, so df.dropna will drop the values. If you put in place equals true, then it will drop the rows in the existing data frame. So once I run it, you will see that at the moment df has got 14 rows, and the moment I run this code, line number 30, you will see that it will drop to 14 minus 4, which is 10 rows. So if I run this code, you can see that it has dropped to, so the original data frame still has 14 rows, but the df data frame has got only 4 rows, has got only 10 rows, because it has dropped all the rows with the missing values. And you can see that there are no missing values in the df data frame. So having dealt with the missing values, the other important thing is to deal with outliers. Now what are outliers? Is that outlier is a value which is unusually high. And again, you have to decide what is an unusually high value in your case. Some people take interquartile range, 1.5 times of interquartile range, as the limit for outliers. In this instance, we'll just keep a simple definition. What we'll do is we'll keep the lower limit as 0.01 percentile. So lower limit. So we will calculate the percentile. So we'll say colName df limit.colName.quantile, quantile 0.01. And what we are saying here is get so quantile, so 90th quantile, 90th percentile would mean that find me the value from the column, and that value should be value so that the all the other values, 90% of the values are less than that value, and 10% of the values are more than that value. So median is your 50%, 50th percentile, which means half of the values are less than median and half of the values are more than median. So we'll get the percentile for 0.01, and then we'll have the upper limit as 99 percentile. So I'll say upper limit as 0.99. So this will give us the values for 0.01 percentile and 0.99 percentile. So when and then what we will do is, so when I run this code, you will get two values, lower and upper. So in our this demonstration, we will make the assumption that anything which is less than the lower limit or anything which is more than the upper limit is a outlier, and we will remove the outlier from our data set. So in order to remove the outlier, we will just create a new data frame, df filtered, and what we will say is that we will say in the original data frame, you pick up the colName, right? If the value of the column is less than upper limit, so less than this one, so this is one condition. Okay, so that's your one condition, and my second condition is I'll just copy this, and that would be my second condition. So df column, so the value of the column should be more than lower limit. All right, so that's my second condition. So what basically I'm saying here is that from your data frame, only select those rows in which the sepal length, the value of the sepal length, right, this column is either less than the upper limit or is more than the lower limit. So only select those rows. Okay, so let me just figure out what the error is. So it says some parenthesis is missing. So this one is this one. So df colName is less than upper limit, and df colName is this one. Okay, so once I run this code, okay, so I'm getting a value error. So what this value error is, df colName, where is my colName is there, is less than upper limit, and df colName is greater than lower limit, and where is my df, let's say I place this as and I try to run it again. Okay, so it has run fine. So so once you execute this, then you will see in the data filtered column, the data filtered data frame, which is this one, it has only got 8 rows, whereas my original data set had got 10 rows. So the reason being, in this original data frame, my upper limit was 7.03. So there was a value 7.2 which was higher than my upper limit, so this value would have been dropped. So in my df filtered, we have dropped that value, yes, and there was a value 4.3. My lower limit was 4.327, so this 4.3 was less than my lower limit, so this value was dropped as well. And so from 10 rows, my filtered data frame has got only 8 rows. So the row number 2 has been dropped, so that's why you don't see any index index with the value 2, and row number, this index 13, has been dropped. That's why you don't see any index. So my filtered one has got only 8 rows. So we have dealt with outliers, and again, a note of caution here that what exactly is your outlier, you have to discuss with the team, with the domain expert, and come up with your own set of definition for outliers. And how do you deal with the outliers in your case? the option which we have taken is to simply drop the rows with outliers. You may want to replace the outlier again with some value, for example, the mean, mode, median of the column. Okay. What we can also do is we can visually see the outliers using a box plot. So if I draw the box plot using df.boxplot, so in the box plot you will see that my original box plot for the sepal length has got some outlier values, but if I draw the box plot for df filtered, then so df filtered, you can see that this df filtered box plot doesn't have any outlier values. Okay, so having dealt with the outlier values, we will then deal with the duplicate values. And as you can see in the df filtered, the row number 10 and 11, these ones, so they are exactly same, so they are duplicate rows. So probably there was some error while entering the data. So we will simply remove these duplicates. So the way we can do is df filtered dot drop duplicates, duplicates, and we will store all our values in a df_clean data frame, right? So once I run this code, you'll have df is there an error? Data frame has no drop duplicated. Okay, so not duplicated is duplicates, drop duplicates. Okay, so drop duplicates, we call the drop duplicates function on df filtered and store the results in df clean. So now my df cleaned is this data frame, and this data frame, you can see that it has got 7 rows instead of 8 rows in the data filtered, right? And in the df filtered data frame, the row number 10 and 11, they were duplicate, and the 11th one has been deleted, and that's why you don't see the row with index 11 here. Okay, so overall what we have seen here is that now I'm going to show you my original data frame. So this was my original data frame, and in the original data frame we had some issues with the data. So for example, in the sepal length column there was some negative values, there's very high values which we know that they are not possible. We had some missing values and we had some duplicate values, and in the clean data set we haven't got any of those problems. I hope you enjoyed the video. Thank you very much.